More on quadratics, this time solving by taking square roots. I've gone back and forth whether to start with a simple one or complex one, so I'm going to start with a simple one. How do I solve for x? Well, the opposite of a square, because you always have to do the opposite to isolate the variable. To get the variable alone, you have to do the opposite. What's been done to the x? The x has been squared, so we're going to take the square root of both sides. Again, I like to keep a nice clean copy, especially in my notes. Maybe not on every homework problem, but definitely on my notes. So I'm going to take the square root of both sides. What I've got to remember is there's a positive square root and a negative square root. And especially people who just came from geometry, they tend to forget that because most of the square root problems they've done were Pythagorean theorem. And since we're talking about real live numbers, we're talking about length, when we're doing the Pythagorean theorem, we don't use the plus and minus. But if we're just talking about abstract algebra kind of stuff, we have to put the plus and minus there. So make yourself a big note, don't forget. So the square and the square root cancel out, and so we have x equals plus or minus the square root of 48. Now, how do I know if I'm done? You have to look at that and see if you can simplify the radical. And in this case, you can. I'm not going to go through in detail in this video all the thought processes of doing it. I'm going to do this one. I'm going to do a factor tree. 4 times 12, 2 times 2, 2 times 6, 2 times 3. And so I'm going to rewrite 48 as 2 times 2 times 2 times 2 times 3. And I'm looking for pairs because square means pair. 2 of a kind. I'm looking for 2 of a kind. I have 2 pairs of 2's, so I'm going to have 4 square root of 3 because this was 2 times 2, right? 2 2's came out, so we have 4 square root of 3. I'm going to direct you to some other places to remind you, give you more practice on simplifying square roots if you need it, because this is going to be integral. It's going to be important for the rest of the chapter, and a lot of things this year, but mostly this chapter. So how did I know I was ready to just take the square root of both sides? Let's write out some steps, and then I'll do a more, circle my answer there. Let me write out some steps, and then we'll do a more complex one. So step 1 is going to be get the squared term alone. Meaning sometimes it's most of the time, some of the time it's going to be x squared that we're trying to get alone, and some of the time it's going to be some stuff in parentheses that includes an x that we're going to get alone. So when I say the squared term, I mean the thing that's got the square in it should be the only thing on one side of the equal sign. So when we did our last short little first example, that was already done for us. We didn't have to do step 1. Step 2, take the square root of both sides. When I say of both sides, I mean both sides of the equal sign. Take the square root of both sides. And don't forget the plus and minus. All right, we have both a positive square root and a negative square root. Step 3 is going to be to get the variable alone. Now, on, again, our short little example, it was already alone, so we didn't have to do step 3. And then step 4, simplify. And again, I'm going to point you off to some other videos to remind you how to simplify if you don't remember how or why or when. So let's do an example that's got a few more parts to it. Let's do x plus 3 squared equals 12. So on this one, is my squared term alone? Yes, because on the left side of the equal sign, the only thing there is something that has a square on it. So I'm going to rewrite my problem because I like to keep a nice clean copy in my notes. Square root of both sides, because again, there's nothing on the left side that's not going to get squared. Don't forget your plus and minus. These guys cancel out. So that was step 2. Step 3, I now have x plus 3 equals plus or minus the square root of 12. I still have to get x alone. So this is the other step I did. This is the step I didn't have to do in the last one. I have to do minus 3 minus 3. Now that 3 is not a like term with the 12. Think about radicals working the way that variables do. So I have negative 3 plus or minus the square root of 12. And then I have to ask myself, can I simplify the square root of 12? Yes, 4 is a factor of 12 and 4 is a perfect square. So I take the square root of 4 out. And again, if you can start thinking of the shortcuts to do that simplifying without having to go through the whole tree, you're in good shape. So there's my answer to one that's a little bit more complex. That one had steps 2, 3, and 4. I'll do one next that has step 1 as well. So sometimes you'll have problems that just have this part, but not the 3 part. Sometimes you'll have ones that just have this part, but not the 2 part. But if you think of it, I want you to think about how this equation looks very similar to the one that I'm going to write that's simpler. Think about it as 2x plus 3 equals 93. If I give you that problem, there's not a person that I know in any of my math classes that doesn't know first I'm going to get rid of the 3 and then I'm going to get rid of the 2. Same steps here to get the squared term alone. We're going to get rid of the 3 first. So we get 2 times x minus 1 squared equals 90. Now we get rid of the 2, same way we always got rid of something that's been multiplied. We divide. So we've got x minus 1 squared equals 45. Now it looks just like the second example did when we got started. We take the square root of both sides, not forgetting our plus and minus. These guys cancel out. We have x minus 1 equals plus or minus square root of 45, and if you already know that that's 3 root 5, you could have done that at the same time. You don't have to wait. I'm just trying to follow the steps I wrote. So we got 1 plus or minus square root of 45, which is 3 root 5. Okay, and again, if I was doing this on my own, I probably would have written 3 root 5. I would have probably written the answer all at once right here, right? Those extra steps are just showing you step by step what I did. You don't have to do all the steps. Once you get to this point, it doesn't matter which order you go in. And I'll do one more example over here just to remind you other things that can happen, other ways that you might need to simplify radicals. And again, I'll point you off to some other resources for review if you need it. Because that looks innocent enough, right? Keep a nice clean copy of my problem. I didn't box my last one, but that's okay. So I've got 3x squared equals 10. I know I'm going to divide by 3. And if that divided and I got something that divided pretty, we'd be in good shape. But we didn't get something that came out nice and even. We have a fraction, which is all right. We're going to take the square root of both sides. These guys are going to cancel out. Don't forget your plus and minus. But what can't we have if we say we need to have our radicals simplified? We can't have a fraction that's a denominator. Or we can't have a fraction that has a radical in the denominator, because that's the same as that. So we've got to get that radical 3 out of the denominator. We can have a denominator, but it can't have a radical in it. So again, I'll point you to some more resources to remind you of this. Why does that work? Well, because a square root times the square root with the same thing underneath gives you just the plain old thing. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is plain old 3. Square root of 30, no perfect squares in there. 30 is 2 times 3 times 5. So that's all we get. Okay, so remember, you can't have radicals in the denominator.